Hello, everyone, and welcome to today's webinar. My name is Remy Rosenbaum, and I'm the VP Marketing at Caserta. I'll be your host for today. At Caserta, we're helping leaders like you who are looking to gain competitive advantage for their companies and to improve their process operational efficiencies, innovate by and through their data. We provide strategic consulting, design, and implementation of today's topic and also across the full data ecosystem. Our data and analytics services are design-led and framework-based, which greatly reduce time to delivery and improve accuracy and impact of the outcomes. Unlike technology-led solutions, our services combine both strategic advisory and technology to align business needs with proven and emerging solutions that drive targeted business outcomes. Our uncompromising dedication to finding the right answer to our clients' tough data challenges while ensuring the fastest time to value is a hallmark of our firm. We incorporate emerging technologies and the latest in design patterns and innovative solutions through modern data engineering. Caserta's complimentary webinars by industry experts like today are designed to give you insight into today's hottest technological trends and issues. After the webinar, you are encouraged to contact us with any questions on how to apply what you have learned today at your firm. Following the completion of the webinar, a recording of today's presentation will be sent to the email address you provided. If you have any questions throughout the presentation, please enter them in the questions panel on the right, and we'll answer them during the Q&A session at the end of the webinar. In today's webinar, you will learn how to build a data lake for effective predictive analytics, business intelligence, machine learning, artificial intelligence, and other emerging data technologies. We'll explore how to implement an enterprise data management strategy by Caserta that will unleash your data to power decisions, fuel efficiencies, and shape the direction of your organization. We will hear from Trifacta and examine a real-world digital transformation use case and see a demo of Trifacta Wrangler in action. We have two great presenters today. We have Vijay Bala, who is the technology and finance leader and senior partner solutions architect at Trifacta. And we also have Bill Walren, principal consultant at Caserta. We're going to begin with Bill. Bill?
Thanks, Remy. Hi, everyone. My name is Bill Walren. I'm a principal consultant at Caserta, as Remy mentioned, and it's my pleasure and honor to be speaking to you today in this webinar. As Remy mentioned, we're going to be talking about the title of today's webinar is Transforming a Data Swamp into a Data Lake. So we're going to be talking about a lot of good concepts for making your data lake as effective as it can be. Let's get started. Again, as Remy mentioned, we're with Caserta. Our focus is on data. That's all we do is data. We are data strategists. We're data implementers. We are helping enterprise organizations get the most out of their data in the cloud. And that's pretty much all we do. That's every day. So let's move forward. Thank you. Okay, so why is this so important? Well, today more than ever, data is everywhere. Your organization just simply cannot be effective if you are not running your business by the data that is available to you. And this is more challenging today than it ever has been. As we can see here, throughout history, data has been accumulating slowly, and then in the last few years, it has just exploded in terms of volume. That's made a lot of opportunities, but it's also made a lot of challenges to get value out of those opportunities. As well as our accumulation of data has evolved over time, so has our use of data analytics. In the beginning, we were just trying to answer simple questions like what happened, what is the current state of my business, and now we're starting to answer questions like why did things happen. And that's very interesting, but now even more so, people are saying, well, if I understand why things happened, can I predict that for the future? And not only can I predict it in the future, how can I make something happen in the future? And then even further, how can I automate certain interactions with the customer? And that's really the evolution of data analytics as it relates to how data is being accumulated in today's environments. Next slide. And as our questions about data have evolved, so have our architectures. Continue through the slide build, please. Thank you. So have our architectures. They've gotten very complex, and as you see here, we have a what might be considered a typical pipeline ETL kind of architecture. And it's we can see a lot of sources coming into a big data lake, and there are a lot of different uses coming out of that data: traditional BI, other big data analytics, data science, other data, other ad hoc querying, and other canned reporting. So today's architectures are having to support a wider range of kinds of activities. Next slide. So dealing with the explosion of data, explosion of volume of data and data sources is our enterprise's top priority. We've got to make getting insights out of this data as simple as possible, and that's where organizations are driving significant change. 43% of all organizations are currently making changes to how they design and deploy information. This is fundamental to how businesses are planning, making decisions, and understanding their customers. Next slide. Not only that, but companies are now innovating through data. So it's a lot cheaper to innovate through data nowadays than to iterate through actual product development. So innovations may fail, but organizations that can't innovate through data will definitely fail. Next slide. Okay, so how does this all compare against how we've historically built data warehouses? So, just as a review, here we have kind of a typical data warehouse plan as that might be considered, a standard sort of plan to build a warehouse. We do a design, either top down or bottoms up. We spend a lot of time creating data models, facts and dimensions. And then we design and build and test complex extract, transform, and load ETL programs to move that data and populate that data into the models that we spent time building. And then we set up data governance and stewardship, business rules, and so forth. Whoops. Can I go back one? Yeah, thank you. And then we put a BI tool on top of all that, and then we can develop reports, and then we can maybe finally get some insights. So there's a lot of good reasons why that was the case in the past, but let's start thinking about a new way of thinking through this. Let's next slide, please. Right. So, and herein lies some of the problem, right? So as we conceptualize some of the historical model for building a data warehouse, the business will say, I need to get some value out of this data. I've got a lot of this data somewhere, so let's make a plan to build to get some data value out of this data. So we set out to collect some requirements. We spend a lot of time building data models. We do a lot of data profiling to understand how our source data conforms to those data models. Then we build the sophisticated ETL programs to do it. We build the semantic BI layer and create the dashboards. And then finally, after 3 to 6 months, we maybe have some output for people to make some judgments about their business. Well, so nowadays that just takes too long. It's too onboarding new data is too difficult. It becomes rigid, and just in general, it's a high cost, slow turnaround time, and eventually just becomes disconnected from the original business goals it was designed to help address. Next slide. Okay, so what do we do now? So we really need a new kind of conversation around data analytics. We need to ask ourselves, do we even need a data warehouse in the first place? And if we do we have a need for it to be relational? Do we have a need for it to be dimensional? Are those things actually valuable for us? Should we leverage certain technologies like Hadoop or NoSQL or the cloud? And really, what we're trying to get at is how fast can we start exploring the data? And why can't anyone start loading data and exploring data? These are the kinds of questions that we should be asking ourselves. And so then that brings us to the promise of the data lake. Thank you. And then, build a site. Yeah, thank you. So the data lake, we can think of the data lake as two ways, right? We've got technology that facilitates the data lake, and then we really have functional capabilities that we're trying to achieve out of this data lake. From a technology standpoint, of course, we're going to be leveraging scalable and abundant distributed storage. That could be, on-premise HDFS. It could be, AWS's S3. Could be Google's GCS, some type of cloud-oriented object storage. And then with that, but separated from that cloud storage, we can use fit-for-purpose distributed processing. So, for example, Spark is a good example. And then later on, we're going to be hearing more about a fantastic tool, Trifacta, that is built for exactly this purpose. Now, the functional capabilities here that we're looking to get out of this data lake are to help us remove a lot of those barriers that took a lot of time to get to insights about that data. We want to remove barriers for data ingestion and analysis. We want to embrace a couple different concepts. We want to embrace a concept where there are do-it-yourselfers out there that we want to enable that they can actually load some of their data and do some initial data exploration. But we also want to embrace more traditional structured loading for a different set of reasons that I'm going to talk about later. We want to use this abundant storage and compute for all of our data needs. We don't want to be constrained by capacity that, there's just so much data out there, I can't use it. No, we want to use as much data as is available and is practical for us to use. And additionally, we want to use just enough governance that is going to be valuable for us. And I'll talk a little bit about the governance later. We refer to this as tunable governance. So let's move on. Okay, so what are the ingredients to an effective data lake? Well, there's a few listed here. So first of all, you want to set up certain zones for certain kinds of data as it passes through any number of steps in the process that you may choose or not choose to include in your environment. So for example, a landing area. an ingested area, possibly a modeled area, archive, and so forth. You want to have zones for separate groups or users. And you also want to be able to support more dynamic ad hoc kinds of operations in a sandbox sort of area. But in your ingest areas, in your modeled areas, your archive areas, you want to implement a fair amount of organization. You want to have and come up with an intuitive namespace design pattern that makes sense for your organization. This part is very important. And as I mentioned before, you want to embrace both structured loading and loading for do-it-yourselfers. Again, later in the webinar, Trifacta is a fantastic tool for doing exactly that. And then just enough governance to keep the data organized and used properly. And then, of course, we want to leverage the cloud technologies to enable our scalability or elastic scalability. All right, let's move on, please. Thank you. Okay, let's just a minute on structured loading versus do-it-yourselfers. So why both of these? Well, it comes back to time to analysis, right? So do-it-yourselfers, we want to embrace what they're doing. We want to embrace their goals because they need to get to some understanding of the value of that data very, very quickly. So this means ad hoc data loads for initial exploration by analysts themselves or the people who are really closest to trying to get to the answers that they need. This means a very low barrier. This means eliminating the barriers to entry to this analysis. It enables rapid assessment of the data value. We get a lot of customers today who know that they have data value or know that they have data sources, but they're not so sure yet if they actually have value for them. So they won't know until they get a chance to explore it in the first place. And then finally, we want to facilitate these short-term analysis objectives as fast as possible. Okay, so if analysts are doing this do-it-yourself loading, and a lot of these analysts have the skills to do this, and they're happy to do this if they can get their analysis jump-started quickly. But every analyst I know and work with on a day-to-day basis is happy and delighted to pass off their regular loading requirements off to a structured loading kind of framework. So the life cycle that we look at here is we have analysts. They reach a point where they like the results that they're getting, but they want to reproduce the same results on a frequent basis. And at that point, now we're talking more about a structured loading scenario, where we have high quality cleansed source data combined with a reliable, repeatable processing ETL process that's optimized for access and sharing and organized for long-term maintenance. So, whereas the analysts were loading data to quickly explore their data, they're not at all interested in making sure that, a load process runs day over day reliably, handles certain kinds of exception scenarios, responding to alerts. Analysts definitely don't want to deal with that. But that's where our structured loading needs to take over. Okay, let's move on. Okay, so governing big data. So before any kind of data governance, it's basically the Wild West. You don't have any kind of master data management, and it becomes a real problem. And the end result is you don't have any trust. You can't trust the numbers because no one's really sure if they're right or wrong. Before big data governance, we have a lot of the same issues, what we want to try and avoid is dumping data into the data lake with no repeatable process at all. And information harvested from an ungoverned system will take us back to the old days, no trust and no action. Next slide, please. Yeah, and then we this is my I like this slide. The data swamp becomes a big monster, and you're just trying to get yourself out of this mess. Let's move on. Okay, so in terms of data governance, what does this actually mean? So in our day-to-day process, we talk about data governance across these dimensions here. Organizationally, from a metadata standpoint, privacy and security, the data quality and monitoring, business process integration and master data management, and lifecycle management. We spend weeks on putting processes and structures around each one of these dimensions. And depending on an organization's specific needs and emphasis, and then once organizations get the idea behind these structures, then their data becomes like a living creature, and over time they can really continue to get value out of their data for years to come. Okay, so this brings us to our corporate data pyramid. We use this model as a model to explain how we think about data in an organization. So, clearly here at the bottom, we're talking about, we're identifying ingested data. This is data at its rawest layer, rawest form. And this can come in at a full fidelity. This might arrive in your data lake at a landing area. But then from there, you want to ingest that data and organize it more appropriately into your data lake. And this is where you have data sets that are cleansed, they're organized according to the namespace that you've set forth, and really available for easy use by any analyst. But then, above that, we have a data science laboratory. And you think of this like an area within your data lake where more advanced data analysis and predictive analytics and exploration can occur. And it occurs based on the data in the data lake that it's founded on, or even other exogenous data that other data scientists may have available and wish to use. But then at the very top, we have a concept of a big data warehouse, and this data at the very top is your most governed data. So this data might be data that where sanctioned metrics are derived. So sales by region. That's where the sanctioned sales by region numbers come from, or number of customers, or number of parts, etc. This is at the top is your fully governed data that is fully trusted and fully maintained. Let's move forward. So, and just in terms of a case study, at our the current project that I'm on is very much a great example of what we're talking about and doing here. So in this financial organization, their goals are these, right? So there are a number of different investment research groups, all having their separate investment goals, and they have needs for data research and exploration. They need access to both their own team private data sets as well as shared enterprise data sets, and they need to incorporate new data sets quickly. And they also need flexible access control. So they need to access enterprise-wide shared data, but they also need to keep their own data private because of either licensing or other restricted policies. So the data lake approach that we're taking with them is we're setting up an enterprise data lake. It's having an intelligent and intuitive namespace to keep data organized. It's going to have both governed and ungoverned data to allow enterprise reference data, but also allow teams to do their own exploration with ungoverned data. We're setting up fine-grained access control so that the data that they need to keep private, they can, and the data that they need to share, there's a pathway to do that as well. And then finally, we're supporting both a structured loading pipeline path as well as the loading activities of some of the do-it-yourselfers who don't know yet that a piece of data is valuable or not, but need to do the exploration work to find out. So this is exactly what we're doing here on the project that I'm on right now, and just as an example of putting these best practices in practice. Next slide. And so that's it. So I think I hope that from this this segment you took away some of the best the reasons for why the data lake can be effective and the certain ingredients that will make it effective, as well as a number of the governance activities that keep it effective over time. And then next, Vijay is going to be talking about.
Yeah, we have Vijay from Trifacta who's going to take it away. Bill, thank you very much. Bill's going to stick around for the Q&A afterwards. And again, you can enter all your questions in the GoToWebinar panel on the right. And now we're going to go with Vijay from Trifacta.
Thank you, Remy. And just before I start talking, just want to confirm that everyone's able to hear my voice and also see my screen.
You're all clear. Go ahead. Thanks.
Okay. Thanks, Remy. So today I'll be talking about data preparation. So first of all, I'm Vijay Balasubramaniam, or Vijay Bala for short. I'm a senior partner solutions architect with Trifacta. And today I'll be covering the concept of data preparation, and we'll be also looking at Trifacta, which is a data preparation platform, and we'll be taking you through a demo of what that product looks like. And where data preparation fits in is essentially an enabler to the data lake architecture that Bill just talked about. So one of the key barriers that comes up often in analytics projects is this notion of data wrangling or data preparation. And oftentimes, data wrangling is a very time-consuming and labor-intensive process. In fact, there is a quote from the former US chief data scientist, DJ Patil, who remarked that 80% of the work in any data project is in cleaning the data. And this is a huge time suck. It's a big problem that a lot of people know about. In fact, there is even a joke that, and this comes from Kaggle founder Anthony Goldblum, that 80% of the data science is about cleaning the data, and the remaining 20% is about complaining about cleaning the data. But all jokes aside, this is a big problem, and there is a big need to approach this in a different way and in a more effective way. And one of the things that we deal with is this thing that's called the data trust conundrum. And like Bill mentioned before, if you can't trust the data, you can't really use it. And there is also in organizations, there tends to be a disconnect between the people who actually have the data understanding in the business context and the people who have the technical skills and the access to the data. So this is the classic conundrum where business users know their data, they know what to do with that data, but they don't have access to or don't have the technical skills to actually wrangle the data themselves. And that skill set and that access lies with a more technical group, which has, which obviously creates a problem. So how do we help to address that? So what Trifacta does is we enable, what we provide is a data preparation solution that simplifies this whole data lifecycle. And what it does is it allows a business user to actually take a much more active role in this process. And you start off with some data, and then the business user is then able to iterate through that data and go through a process of discovering the data, structuring it, cleaning it to address any data quality issues, enriching it to augment it with additional data sources to add value to the data, and then also validate that the data is of sufficient quality. And this is a very iterative process shown in the circle here. So this can happen over and over again. But the good thing about Trifacta data preparation is that the business user can go through this cycle extremely quickly, extremely rapidly. And once the data is coming out the way that it is supposed to, at that point, IT can then automate this whole pipeline. And then you have something that is not only rapid time to market, but also repeatable and of sufficient quality that it can be used on an ongoing basis. So in this page, we're looking at the corporate data pyramid. Again, Bill covered this previously. So where does Trifacta fit into all of this? And so the answer is we fit into the intersections of the various layers of the corporate data pyramid. And what Trifacta provides is a mechanism to actually wrangle data, and this can be done by various actors in the whole data ecosystem. So for example, a data engineer might actually take data from the landing area, which is raw data in its source form, and use it to apply some basic cleansing and add some structure to the data in order to ingest it into the data lake. Now, once it's in the data lake, then a data scientist may actually then take that data and consume it within their data science workspace. Or an end user might also come into the data lake and draw from some of the information contained in that data lake. And these people might actually do some additional data preparation. In the case of the data scientist, to maybe prepare it for ML models. And in the case of analyst, it might be to create some kind of a BI report. So the basic takeaway here is that Trifacta can be used in any of these areas of the corporate data pyramid as a very effective data wrangling tool in order to prepare data for downstream processing. Now, here we talk about some of the recognition that Trifacta has received in the marketplace. On the top, we have the analyst report. So we have been recognized as a leader in the data preparation space by Gartner, by Forrester, by Bresner, Ovum, and a number of other analysts. We've also received a lot of customer accolades in a variety of industries, including pharmaceuticals, the financial services, and retail, and many others. And the bottom half of the screen here, these are essentially some major software partnerships we have with all the major cloud platforms. So that includes AWS, Google Cloud Platform, and Azure, as well as with many other software ecosystem partners. And we have invested in integrating into these platforms and these software architectures in order to provide a more effective solution to our customers. Now, in this page, we talk about integration and how Trifacta can actually sit on top of various platforms and essentially also provide an abstraction layer to future-proof some of your data preparation investments. So the idea here is that you can use a tool like Trifacta to declare your data transformation in an abstract form. And then regardless of what you use for your underlying execution infrastructure, and that could be on-premise or it could be on one of the major clouds, we support execution on all of those platforms. So we provide connectivity to a variety of data sources on all of these data platforms. We also integrate into the security and the access controls and the lineage and catalog richness that is provided in all of these platforms. And essentially, even if some of these components change over time, the benefit is if you've built your transformation recipes in Trifacta, you can reuse it on a different platform, or you could use multiple platforms to leverage your data preparation workflows. So I'll stop there in terms of the slideware, and the next thing I'm going to do is go right into the demo. So let's get started. And the demo I'm going to be showing today is a basic marketing analytics use case. And this involves creating some analytics in order to prepare a BI dashboard. And an example of that dashboard can be found here. This happens to be a Tableau dashboard, and it shows various components such as profit by state, order value by year, and sales by source. Now, we have some raw data to work with. So let's look at how we go about converting that raw data into this finished dashboard. So the data sources that we have at our disposal are a couple of them. We have some advertising clickstream data, which happens to come to us in a CSV file. And we also have some sales data, which originated in a relational database. Now, the nice thing is in Trifacta, you can bring data from any source, and you can have a seamless way and very consistent way of working with those data sets and also be able to join them together right within the UI. So the first step in any data preparation workflow is to add your data sets. In this case, I have already brought in these couple of data sets. If I wanted to bring in more, I can click on Add Data Sets, and then here go to Import Data Sets. If I happen to have files lying around on my local desktop, I can easily browse my local file system and pull in what I want. Or I could pick one of the predefined connections that my administrator has set up for me. Or I could also set up a new connection. And here you have a very rich library of different data sources that you can connect to. And that includes major big data platforms, relational databases, and cloud platforms. So this is step one in most, in pretty much every data preparation workflow, is to bring in the data sources, which in this case I have already done. Once you've brought in your data sources, the next step is to actually start wrangling it. And that is achieved through what we call as a wrangle recipe. So I'm going to go ahead and click on Advertising Clickstream and go to Edit Recipe. And you'll notice that when this comes up, you get a very familiar Excel-like grid view of the data with some important enhancements provided to you. So you can, as an end user, browse all the fields in your data set. You also get automatic type inference. So it tells you what are the field types, whether something is a date or a string and so on. There is also a data quality bar, and this is really useful because it alerts you to potential data quality issues you may have lurking in your data. And you also get a value histogram. So this gives you a high-level distribution of how my values are distributed in my data set. Now, I can actually also get a lot more detail. But before that, let me take a quick look at this data quality issue that I see here. So it looks like I have some different representation of dates. So I might want to explore this a little further to hone in on some of these data quality issues. Now, I can go into column details on any column, and that brings me to this view. And this is something that is designed to help you understand your data and also address any data quality issues. And right off the bat, I noticed there are a bunch of mismatched values, and it looks like there is a bunch of timeouts in my timestamp, which is obviously not useful data. And what I can do is I can interact with these visualizations, and then choose from one of the suggestions that Trifacta gives me. And this is a hallmark of the Trifacta user interface. As you work with the data, you get immediate suggestions that are generated by our machine learning algorithms. So in this case, one of the suggestions is to delete the rows where the time is showing as error timeout. I'm going to add this as a step to my recipe. And notice that it's starting to build a recipe of various transformation actions. So that addressed some of my mismatches. Now there are some more issues which I can discover by going to the patterns tab. So the patterns tab tells me all the various representations of this date that are contained in my data set. And it looks like there are some variations here. In some cases, I have a month abbreviation, so it's NOV is spelled out. And in other cases, I have the month represented as a 2-digit date. Now, this is obviously not the best way to have formats all over the place. The nice thing about Trifacta is if I simply select the first one, and let's say I want to convert everything to this format, I can simply choose the suggestion to convert all of my dates to a common format. And it's really as simple as that. And as soon as I apply this, you will notice that my data quality bar is now showing a solid green. So everything looks good. And I'm ready to proceed to work on the remaining columns in my data set. Now I can also, as I browse this data, use this value histogram to discover potential spikes or outliers. So for example, here on the user ID field, I noticed that there is a big spike in the user ID. Now, if I wanted to investigate this, I can take a deeper look at these rows by clicking on show only affected rows. And it looks like all of these clicks happened by the same user ID at the same exact time. So this is obviously some kind of data quality issue. It could be that there is some kind of a bot that is hammering away at the system. So this is bad data that I want to get rid of. So again, I'm going to choose the delete rows option here and then add this to my recipe. And now if I look at the distribution of my user IDs, you'll see that it's a much more even pattern. So notice that all of these visualizations are refreshing on the spot as I'm doing my transformation recipes. And it's also possible to go back in time and look at the data at any previous step simply by clicking on that step. So now that I got my user IDs cleaned out, I need to do a couple of things with this URL. So one of the fields that, if you recall, in my dashboard, we cared about the source of the click stream. And that is actually contained in this URL somewhere, so within the actual URL. So if I click on this URL field, notice that Trifacta already knows that this is a URL field. You actually get one of the suggestions is to pull out the domain name from the URL. So if I select this, notice that I get a live preview, and you get a live preview for every step of the way on each transformation. And it shows me that the URL pulled out into its own field. I'm going to add this to my recipe. And I'm also going to rename this particular field. Instead of domain URL, I'm going to call it source. There's one more key piece of information that I care about from this data set, and that is the product ID. So I can actually pull out the product ID simply by, it's actually tagged to the end of the URL. And I can simply use my mouse to select what I want. And I will automatically get a suggestion to extract those values into their own field. So it's as simple as just accepting the default suggestion, and then I can go ahead and rename this field and call it product ID. So now I've done some basic preparation on this data set. Actually, there's one more thing I wanted to show you, which is more from a machine learning standpoint. So oftentimes when you're building machine learning models, you're dealing with categorical information, and many machine learning models require that you convert those into numeric data field. It's a process called one-hot encoding, and that's really easy to do in Trifacta. So if I simply choose this device type, notice that there are 4 different device types, and I can easily convert these values to columns by choosing this option, and notice that it creates 4 different columns for computer, other, smartphone, and tablet, and populated a value of 0 or 1. So this is what we call as one-hot encoding. This is very useful for machine learning applications. So I can add this to my recipe. And next I'm going to switch to my sales data set. And in this data set, this actually contains transaction level information for my sales orders. And so this is actually contained in a master detailed format. So I have sales orders, and I also have sales order lines. If you notice this last field here, it's actually like a JSON string. It has an array of nested objects. And my first task is actually to break this out into its component pieces. So if I select the sales order lines, one of the options that comes up is to flatten this into its own array. So this is going to create multiple rows for each sales order line within my data set. And then notice that this is now consists of key value pairs for my sales order line, which is the individual fields. If I select this, I get the suggestion to unnest this JSON key value pairs into their own fields. So here you can see discount, due date, freight, and so on. So they've broken it out into the individual fields now. So I can add this to my recipe. Now, on top of this, I can actually create my own derived fields. So in addition to what I get from my raw data, I can actually use some of the features of Trifacta to derive some fields. So the first one I'm going to do is recall that in my dashboard, I actually need a year field, and I can easily create that by going to my order date, selecting extract, and use one of the date time extractors to pull out the year from the order date. So you see that I got the year from the order date. I can use the same method to pull out any other date component that I wish to. And then I'm also going to create, based on total sale and total cost, I actually need to create a profit column. So that's also extremely trivial. So I can basically just do a new formula, do total sale, total sale 1 minus total cost. See that I get an immediate live preview. And then I can call this new column as profit, and then add that to my recipe. So it's really that simple to create calculated metrics. Now, the last step I'm going to do before I produce some outputs out of this is to actually join this data with my advertising clickstream data that I wrangled before. I can simply do that by clicking on join, pick the advertising clickstream data. Now, I'll be asked a couple of questions in terms of how I want to join this data. And I can actually tweak these suggestions. So I can choose from joining it based on product, or in this case, I might actually want to do it based on a customer key, which is called as a user ID. So I can choose, what I'm joining based on. I can also choose the type of join, whether I want to do an inner join, left outer join, right outer join, out or a cross join. In this case, I'm going to stick with inner join. And the next step is to then select what fields I want in my output. So in this case, I can go with all the columns, or I could pick and choose the columns that I'm interested in. And then I can then finally click on the review button and add this to my recipe. So what this does is it then immediately gives me a preview of what the data will look like after the join. And then, so this is now a fully joined data set. I have 46 columns. I can continue to pare this down and skinny it down to just the fields that I need. Or I could just go ahead and run a job. So that's the final step in the transformation flow, is to run a job, and you can then choose your running environment. And also you can choose the type of publishing action. So you can create a CSV file, or you could also create one of the other formats such as Tableau data extract, or JSON, or Avro, and Parquet. And then I can basically click on Run Job. I've already, for the purposes of this demo, I've already run a job previously. This will, so this is what you will see after the job runs at scale. And keep in mind, you could be running this against gigabytes, terabytes, or even petabytes of data. And you get this output, you get a detailed profile of your output results. And so you can browse through all of that. It gives you a snapshot of how many rows were created. And from here, you can continue to export your results. And in this case, I created a Tableau data extract. So I can then use that to finally create my marketing analytics dashboard. So hopefully that gives you a full picture of how we go from raw source data to a fully prepared and completed dashboard. So I will conclude the demo at this point and pass it back to Remy, and we can also handle any questions that people may have during the session. So Remy, over to you.
Thanks. That was a great demo and very insightful. We're now going to open it up to questions, and we do have time for a couple good questions. I'm going to start with you since we just finished the demo. We have a question. In which clouds is Trifacta available?
So Trifacta is actually available in a variety of different platforms. So you can actually go to Amazon Web Services, and you can just pull up an Amazon machine instance or an AMI, and we can deploy to Amazon that way. We are also available on Azure. So on Azure, we are on the Azure Marketplace. You can pull us from there. We also integrate into all of the cloud ecosystems in a fully integrated way. And then on the Google Cloud platform, we are actually embedded right in the platform as Google Cloud Data Prep. And in each of these cloud platforms, we are fully integrated not only into the virtual machines, but also to all the other parts of the cloud ecosystem, such as, for example, in AWS, we integrate with S3 and Redshift and EMR. If you talk about Azure, we integrate with HD Insight and Databricks and Azure Data Lake storage. So a wide variety of cloud integrations are available. And if you choose not to go the cloud route, if you want to keep things on-premise, that's possible too. So we have a very robust mechanism to install on-premise on your Cloudera or Hortonworks Hadoop cluster.
Okay, thanks. This one's for Bill. Bill, how much does putting into place a data catalog system impact keeping the data lake from becoming a data swamp? And what does Caserta do regarding this? You mentioned obliquely through master data management, but can you expand on that?
Great question. So one of the problems that sometimes occurs in continuing to get value out of the data lake is to understand what data is out there, right? So who put what data where, and what is it for, and what is it about? So this issue can start to get pretty very troubling very quickly if we don't have some kind of map to what data is out there and how to reach it and what it's about. And that's where the data catalog comes into play. So the concept of the data catalog is exactly that. It's a catalog of that what's in the data lake, how to use it, what's the origin, and how it might have a impact on my particular analysis, and as many other details as your organization might need to keep itself organized. So there are, as it is, one of the things that we do at Caserta is plan and implement the data catalog concepts. And there's a variety of solutions around doing this. And at Caserta, we've got a sort of a methodology for planning this out, gathering the requirements, and then implementing it on an iterative in an iterative fashion. So great question.
Thanks. We have one back for Trifacta. Can Trifacta treat real-time data, for example, from Internet of Things devices?
Yeah, that's a great question. So a lot of times what our customers do is they often encounter streaming data that comes on the fly from various devices and things like that. And it is often a great challenge in terms of processing. First of all, it's voluminous, and also it's extremely frequent. Trifacta actually offers some scheduling capabilities to actually, once you've designed your data pipeline, you can actually repeatedly execute that in micro batches. And so as your data comes in, you can pass it through that pipeline and produce your outputs. So that's certainly possible. And also we provide very robust tools in terms of orchestrating with other tools as well. So we have a fully featured REST API. So you can call Trifacta with that, and you can integrate it with other parts of your data ecosystem. So you might be using Kafka or some other stream processing engine for your initial ingest, and then you might use Trifacta as a downstream consumer of that Kafka information, and then you can use it for joining it with maybe data from your data warehouse. So all of that is possible, and there's robust scheduling available. There is a rich API that you can use to orchestrate all of that and produce the results that you want.
All right, thank you. And I think we have time just for one more question. Bill, this is back to you. In your financial organization case study, how much reuse in data pipeline architecture are you applying in this case from other clients? In other words, how much of this process is repeatable versus customized per client?
Great question. So in our work at Caserta, we find a lot of reuse between our work among our finance clients, but not 100%, but quite a bit. And so at Caserta, we've come up with a framework to establish a reliable, robust ingestion pipeline. And our ingestion pipeline in this case, in our use case that I talked about earlier, is exactly what we used, and it's working out very well. We take data that's landed in a landing area of the lake. We use our framework to ingest that data that creates a very cleansed version of that data that's saved in an organized namespace and in a Parquet format. And then in this case, this financial client, then the analyst here can then do their analysis off of the ingested data directly after that step. And as we look across the interests of the other analytical groups here, we can tell that that same framework is going to have a lot of reuse with the other data sets that we're looking at for their future phases.
All right, and thank you, Bill. That's all the time we have for today. If you have any further questions for either presenter, please reach out to me at remy@caserta.com. That's REM as in Michael Y @caserta.com. Thank you, everybody, and the recording will be sent out after the presentation. Take care.